Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later. We will be sending out an email later on today that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. We'll get to as many questions as we can near the end of today's webinar. Okay, with that, we'll go ahead and kick off today's webinar, which is the impact of digital transformation on enterprise security. This is a great topic. I'm really excited about this one. Our speaker today is John Steven, who is the CTO over at ZeroNorth. Hi, John. How are you? You with me, John?
Thanks.
All
yes,
right,
absolutely.
great. Perfect. Well, I'm going to put myself on mute, let you get right to your presentation.
Terrific, thanks. Good morning, good afternoon, good evening, everybody. Thanks for attending. I want to talk a little bit about digital transformation and how we've seen digital transformation affect the way that firms run their security initiatives. ZeroNorth conducted a survey on this, as well as other surveys have been conducted on this. And though digital transformation is a hypey or buzzwordy kind of concept, what we find is that when Gartner or the BSIM community or ZeroNorth conduct survey, we actually see people modifying the way that they're running their security programs based on this concept of digital transformation. And so we wanted to dig into when you talk to firms about what they're actually doing, what do these terms really mean to them, and how are they affecting the way they're going about their business of security, in particular how they're going about the business of security as it pertains to these cultural imperatives, digital transformation, DevOps, and some of the older ones, automation and moves to the cloud. And what we can say definitively at this point is that survey data from a broad swath of industry participants, from a broad swath of surveys, has shown that people are affecting the way that they go about the business of application and cybersecurity because of these functional and these business trends. It's not something we could say 3 to 5 years ago, but it is definitively something that shows up in the data today, and that's what we want to talk about. So as we talk about this, the first thing we have to do is demystify these hypey words, and that's what we'll start with. Up in the top right of this slide, you see a graphic that I produced, maybe let's call it 5 years ago, demystifying the difference between Agile, CI/CD, and DevOps. It was getting to the point, as people will remember, that people were Agiling their DevOps for CI/CD. They were just using the terms almost, as badges. On a Friday's waiter's outfit to credential themselves and adorning themselves with as much use of those terms as possible. So adopting this kind of, convention of saying, well, if you're focusing on CD, then you're looking at, creating a software-defined lifecycle. You're really highlighting tools, and your focus is automation. If you're focusing on DevOps, you're probably looking at culture. So let's take that and let's apply it to digital transformation and ask what does it mean? Well, what we found through various survey means is that digital transformation probably has about 5 pillars associated with it. And those pillars are not created equally in terms of the amount of adoption that they have in the industry and what they entail. And so, what we have here is, everybody is really, and I call it table stakes, everybody is really, aggressively going after open source and you building more and more of the software on which their business depends on open source. They're also over the questions and the risks and the difference of using cloud service providers and a move to the cloud as opposed to sequestering everything in their own data center. And this really, when you look at it, is a form of outsourcing. It's not outsourcing your development team to India or somewhere else, nearshoring, offshoring, but it's outsourcing the broader capabilities of IT. And what's interesting about the dichotomy between cloud service providers and open source is that they mirror, in an outsourcing context, the DevOps movement. So when you move to a cloud, what you're really talking about with a firm is outsourcing infrastructure as a service. And when you move to open source or reliance on open source, what you're doing is you're accepting development help, and more of what you deploy is developed by open source providers. And so, broadly taken, right, what this highlights is that firms are beginning to allow developers to make their own choices about open source and use the cloud. And so engineering is self-servicing. And this effectively outsources IT, infrastructure as well as dev. But self-service comes as a double-edged sword, like most benefits, with a cost. And so when you allow people to self-service, it becomes more challenging to centrally govern them. And we see a lot of that stress, in security initiatives as people adjust. If outsourcing is table stakes, where people move next is to focus on culture and automation. And this is where people are beginning to struggle, or organizations are beginning to struggle, or security initiatives are beginning to struggle. If you're going to allow people to use a much greater extent of self-service in their infrastructure and their development, then the culture has to change. And, working with a centralized governance model of stopping people's development to run proactive governance through assurance has to become more responsive. And so as we break down the roles and stovepipes in firms with a DevOps movement, we have to focus on increasing the delivery and the responsiveness. The security analog of this is we have to figure out a way to increase the responsiveness of security governance activities. And this comes at a time where we've reached a relative maturation of a legacy tool set as it pertains to vulnerability discovery and infrastructure and application security. And so what we have is that those mature tools that are doing a more thorough job tend to take a lot of time, and that time that they take is going to create a stress when in DevOps our cultural imperative is to go to increased responsiveness. So as the cadence of our development increases, we're more challenged by the maturation and the thoroughness of the tools that have also progressed through industry. And so whereas outsourcing was table stakes, the cultural imperative and security's participation in it becomes a challenge. Whether that's your own organization's Vietnam or Afghanistan, you can pick your metaphor. But that's really a place where security has struggled to participate. And it's because of the focus on responsiveness and the stresses associated with cadence. Unsurprisingly, they're addressing that with a highlighting of tools and an emphasis on automation. How do we take the governance activities that we did by hand, perhaps artistically, perhaps expertly, and how do we reduce the amount of expertise or manual intervention required so we can meet that cultural imperative at the speed and cadence at which it operates? The level of effort on this automation can be overwhelming because of the number and the variability and frankly the brittleness of the technologies development is using to manage their own automation activities, automating their pipelines, conducting continuous integration and continuous delivery or deployment. And so in order to apply security governance to what we've outsourced, we need to move at the cadence of the culture, and that's caused us as firms to rely on automation. But we're struggling because the tools we use are maybe slower than we need them to be to keep up with cadence, and the level of effort associated with the, in some sense, bespoke integration with every development team has been a challenge. And so, ultimately speaking, that has those challenges, those killing fields of security initiatives have have made it challenging for firms to get to what I call the brass rings of digital transformation from a security perspective, which are creating true end-to-end software-defined security governance, and replacing all of those organic mechanisms of security governance with software. And what we're noticing in firms that have gotten to this level of maturity is that we're actually seeing pushback from some of the best and the brightest within security initiatives who may either subconsciously or very explicitly feel threatened by the replacement of their existing, sort of career path and their job by automation. Two things strike me very interesting about this. I know 3 CISOs with whom I'm close who left their job as CISO at a fairly high-profile organization and ended up as an individual contributor and, frankly, a DevOps engineer focused on security in another firm. Did they get demoted, and were they not cut out to be a CISO? No. The answer is that they transformed and evolved, and in their new roles, they're applying leverage by producing software that the organization uses across the portfolio at scale, rather than making dictums or mandates that the organization rolls out at scale. The second thing that caught me about this kind of leverage is that in giving a former presentation at a conference about automating security initiatives, a very accomplished VP of vulnerability management came up to me afterwards and about 3 inches from my face yelled at me for about 45 minutes, showing that there really is a very personal reaction to this kind of automation. And so we struggle because of culture and automation's challenges, and we struggle because of the human factors to get this leverage we'd like. And frankly, honestly, it's not just a people problem, it's an architectural problem. Some firms will find that they cannot get the cadence and the level of automation that they desire with what they've outsourced to unless they move to a microservice architecture. And changing convention and the way that, the paradigm of development or the way that software is structured is very hard. And so firms may lack the resolve or the follow through or frankly, the subject matter expertise to get microservice done correctly. Certainly in my own firm, we publish microservices, right? But we find that we still have to deploy big chunks of our software as monoliths, regardless of how they're built as microservices. And so that kind of highlights that even if you're a young firm and you're agile, these things can be a challenge. And so we get these benefits from how we're evolving as a software industry, but security faces these challenges as they address them. And this is not something that is maybe news to people, but I hope that this view of things makes it more salient. So what does software-defined security governance entail? If that's the brass ring that we're reaching for, how do we identify it? How do we break it down into its pieces, and how do we get after it? Well, we asked about 20 development, DevOps luminary firms. You can imagine the kind of logos we're talking about here. I won't name them. What they did when they made a security transformation and when they made a DevOps transformation. And these are the things on the left that they said that they did. And I've highlighted pieces of it. They said that, rather than providing detailed vulnerability discovery, actually the number one problem we have is getting visibility to what we're actually running and keeping that up to date. And that's become an API problem, not just an open source problem for us as a firm. And we want to remediate security defects, not using best of breed security tools, but we want to use those tools that developers are already using so they don't have to swap back and forth across their workbench to different things that give them cognitive friction. And we want to co-opt the orchestration that they're using. So I've distilled that into what I believe is, because it's sort of a wall of text, I've distilled that into what I think a quick and dirty checklist for a modern engineering-led security initiative looks like. Modern security, engineering-led security initiatives will have good software-based facilities to inventory their software, their services, and the data they make available in the cloud, as well as through data centers. Moreover, they will have software that helps them continuously discover how that asset base evolves and changes over time, and they'll be able to characterize their attack surface with software. And they will parlay that visibility into what they need to put under management with integration of maybe simpler tools as opposed to commercial big box tools. They give them visibility to their security posture, but well integrated with, baked into their pipelines. And they will co-opt those very pipelines to actually produce a control plane, or in other words, harden and secure the software that they're deploying without them being security, having to interact with development teams. This is a very different view than we've historically seen out of security initiatives. 15, 20 years ago, I prototyped this diagram, which became kind of a de facto standard. We called it the touch points for security. And you can see the difference between this view of the world, where you create something in software, first requirements, then design, then code. And then you stop based on what you've created and you analyze it for bugs. So you take your requirements and you create security requirements or abuse cases. You take your design and you threat model it. You take your code and you scan it. You build your code and you scan it. You deploy your system and you test it. This is a very different set of touches than these touches here over on the right. And this is the first key realization that those who own security initiatives need to make, that the focus has shifted from proactive security governance through these assurance gates, where you build something and you stop to test it, to what I call continuous telemetry and resilience through co-opting the pipeline for security and hardening. And of course, this is based on that desire to meet these key challenges you see at the bottom here. The fact that people are self-servicing at a high rate of speed, and that their incentives may countervail moving beyond this well-ensconced and optimized set of testing regimen and conventions. And so if you look at the building security in maturity model, or the open SAM model for how security initiatives grow and change over time, over the bulk of the last decade, two things have been dominant. You create code, you scan the code. You create systems, you scan the systems. And so commercial static analysis, or SAST, and commercial dynamic analysis have been dominant in the vendor space, especially in sort of the former of the last 2 decades. As measurement and analysis of security initiatives changed through the recently released BSIM 10, as well as a recently conducted DevOps study, which I did with some colleagues, we see that these two dominant vendor players still exist, but people are beginning to use more and more open source as we've seen the dynamic market commoditize. We've seen container security come into play because, one, containers have become popular, but also two, people view containers, they're a functional choke point and a standard gestalt for deployment, and they can therefore be a security choke point, a single point of visibility or control for security initiatives. And so some younger initiatives have begun to ask the question, can I create a fulcrum around containers for the entirety of my visibility program? Maybe yes, a lot of people think no. The older, more expensive stalwart static analysis has itself seen some evolution, and so big box and commercial static analysis has become simpler with some of the more recent players, and open source has become more prevalent. And what we see is, in fact, people are sometimes replacing their commercial static analysis with frankly, entirely open source that they run as either buildless on their repos when people check in, or when people publish pull requests amongst development teams. And they're also home rolling static analysis to manage the other piece of code that's the dirty secret in organizations, where they orchestrate their software. Remember that if we're successful in making a DevOps transformation, then our infrastructure and the way we orchestrate our infrastructure, that becomes code. And so if it's code, then we may want to scan that code for obvious screw-ups or vulnerabilities, or maybe credentials or secrets stored there. And so what we've seen, not so much in the formal open source space, and definitely not in the commercial space, but we've seen firms roll their own static analysis to answer the question, have my DevOps engineers done anything boneheaded as they've built out software, infrastructure as software. And this is interesting, right? So in our own firm, ZeroNorth, what we find is that, not a majority, but an overwhelming minority, maybe as much as 40% of our code for our platform is infrastructure. And so if I as CTO/CSO wanted to go out and ask the question, are my DevOps engineers making any of these mistakes, like hard coding credentials into that orchestration? Are they committing that to repos that may be shared between a large number of staff or even public? Am I making connections between software that violate our own sort of security policy? We have to, as a firm, write that logic ourselves to check for it, oftentimes. And so we see, again, a reliance on sort of formal commercial research becoming a reliance on open source as the static code market matures, and home rolling it as orchestration matures. We've seen the introduction and the popularization, especially over, I'd say, the last 18 months. There's been a lot of noise in the past, but there's a bit more traction now in terms of IAST. IAST being basically agent-based technology, working much more effectively for Java and .NET than some of the other platforms, that sits in an interpreter and helps, whether you're doing testing or whether you're doing dynamic analysis, increase the coverage of those analyses by conducting agent-based, binary static analysis. Think of these tools as kind of a turbocharger for your testing regime or your dynamic analysis regimen. They're really going to perform much better in terms of thoroughness and accuracy than the dynamic analysis tool unassisted. And just like a turbocharger on an engine, they produce that dual benefit, right? So a turbo gives you more power and it gives you more gas efficiency than a bigger engine would. IAST gives you more coverage as well as more accuracy. That's rare for a tool. Some of the commercial vendors of IAST have chosen to pit IAST against static analysis, claiming that static analysis is low accuracy and too challenging to implement. I think some of their comparisons are interesting. I think generally speaking, that's a dangerous comparison, because again, there are things that IAST or that DAST or that SAST will individually and uniquely find, but IAST is best suited to complement and augment dynamic scanning, because it needs to be driven as a technology by one of those engines, and can't simply be used on its own without something turning that metaphorical crank. But we definitely see firms looking at evaluating how much can I rely on IAST in order to augment my existing regimen, which may have become commoditized. Firms are spending non-trivial time replacing some of their own efforts in vulnerability detection with work on integrating vulnerability detection into the functional pipeline. And in that regard, taking away from some of the sort of implementation and triage that happens above this water line in the diagram, and working on some of the plumbing that drives the water below this water line in the diagram. That's why you'll see a lot of security champions and SSG members, security group members, going on, if you will, sabbatical to whomever runs the Jenkins pipeline or whoever runs GitHub for a team, and working on not implementation of a scanning tool, but integration with that tool and the environment. We're beginning to see sprouts and shoots of those same individuals writing scripting, as I mentioned, to answer questions. How does the software actually get constructed in production? What is the attack surface? What am I running I don't know about? And what's interesting about this discovery capability, unlike some of these other capabilities you see in the diagram, is that discovery is necessarily a multidisciplinary pursuit. So you need to look at things throughout the life cycle, things that are strictly dev, like what's checked in, the interface between dev and ops, like the registry and orchestration, and then things that have strictly been the provenance of ops, what telemetry comes out of production. We've seen firms handle discovery in a bunch of different ways. In the vSIM study version 10, we found that firms are unable to find vendors to help them with discovery and pipeline integration typically. Discovery in particular is something that firms have taken a multi-pronged and home-rolled approach for. In other words, they're writing their own software to tackle this problem internally. And then finally, firms are not satisfied with simply getting better visibility into the attack surface and what may affect the security of that attack surface. They are seeking a control plane or the ability to manipulate and improve the security of their pipeline, of what comes out of the pipeline, with hooks out of their existing tools, with new plumbing, and with new tools. Some people call this virtual patching. Some people call this, control plane. It's sort of new. A lot of firms are experimenting with it. Not a lot of firms are relying on it. But when you look at the difference between like a Sneak.io in terms of composition analysis and some of the legacy players, you see that virtual patching, pull request generation. When you look at firms like a DivvyCloud, which will drive not only guardrails on your cloud management, but also again policy enforcement. When you look at what's happening in Twistlock or in Aqua with container security, they give you telemetry, but they also give you the ability to harden. We see vendors across the board adding to detective capability with control plane capability. So, unrolling this automation, you see a big difference between the way we thought about things a decade or two ago and what the evolution in our tool set has been. So as you consider what your own firm does in terms of tooling up to deal with its governance controls, ask yourself the question, where do I sit along this continuum? And how prepared does my tool set make me for those pillars of the digital transformation and the challenges that security will face along the way? Instead of looking at the touch points diagram or looking at the way the vendor community has responded to this, let's look at the way developers or development management may think about your life cycle in DevOps-centric teams and what that might mean for security vendors or what that might mean for security initiatives in terms of how they interface with this pipeline. So the first thing you'll notice about this sort of modern view of the life cycle is that it's circular. So it is intended to be a tight loop. You'll notice that it's not a mistake that dev and ops are sitting next to each other in the diagram, because we expect a tight degree of collaboration and feedback from them as those stovepipes melt away. Maybe counterintuitively, let's start at the bottom left of this diagram with the IDE or SCM. Let's talk about this, but let's consider that everything sort of below development here is the wheelhouse of development and tools maintained by development and engineering, with the exception of the artifact repository, which is put dead center north to south in this diagram, but on the right, because it is the interface between dev and ops. This isn't the infinity diagram you typically see associated with CI/CD or DevOps, and you'll see why in a minute. The first thing that firms do, and I think this is often overlooked, is developers make a decision about what they're going to incorporate from a cloud or from an open source perspective. And so it's not that you sit down and write your first line of code in the IDE or in DI or Emacs or whatever your pleasure is. It's that you decide whose code you're going to build on. And we see this in the Java framework environment. We see this in the JavaScript environment, and we see this with the selection and all of sort of the pregnant choice that comes along with, selecting Go or Python or Ruby. Your first order of business is to decide what you're going to build on and what frameworks you're going to use. And so in that regard, your first action is a clone, a fork, and when you do that, what you're really looking for is greater visibility into what the composition and what the security properties of the thing you're downloading are. So if you're writing on top of JavaScript and Node, are you using frameworks? Yes, of course you are. Do those frameworks support contextually aware output encoding? They probably do. So you're not going to have some of the challenges with the OWASP top 3 you have. Whereas in Java, if you're using some of those frameworks, maybe they don't yet have contextually aware output encoding, so maybe you do have that challenge and it's something you're going to have to code against. How do they do password storage? How do they do encryption? How do they do encoding? How do they do filtration? These are all elements of a nutrition label that our open source nexuses don't maybe give us the best view into. Something our composition analysis tools don't give us the best view into, but something implicitly we have to answer when we pull these things down as developers. When developers develop on top of these things, they have a bevy of open source stuff that they can apply from a security perspective, whether it's well integrated into their environment or if it's sort of POSIX-like and sort of, code in, results out. And the open source community has, depending on the language, pretty robust support for helping developers get visibility into what bugs they're introducing in their code based on dangerous functions and similar things as they code. Because we're trying to give developers instant feedback at this phase, understand that the scanning technology has to be instantaneous. Just like nutrition labels and the composition analysis has to be available to me when I go out to the repositories to discover what I'm going to pull down. And so it's unsurprising that some of our really thorough and legacy tools don't fit here. And when we've tried to bang those square pegs into those round holes, they don't fit. And they create a lot of developer friction. And there's immediate pushback with pitchforks and mauls because we're affecting someone's workflow. Unsurprising then that open source has begun to take over here because that open source can be written to be simpler, to be more responsive. Whether we're doing a commit on the way up or whether we're doing a pull request that someone else is going to analyze and decide whether to approve or not, I think we go from instant to seconds, and we can spend a little bit more time analyzing something. We still want it to be near real time, but we can spend the time to ask the question, has the developer not only done their hygiene with making sure they avoid dangerous functions? Did they use the framework's security controls? Did they follow my security policy before I approved the PR, and so on and so on? Again, a lot of legacy commercial tools are going to fall down in this life cycle phase because they don't move this quickly. If we're taking the time to build the software, there seems to be, and I cannot explain this, but it is held true for a decade or more, there seems to be a magic number. People who maintain builds want builds to happen under 7 minutes, or even when those builds are 45 minutes, they want a security tool to run in under 7 minutes. I don't know why that number keeps coming up in my life. I don't even really like the number 7, so it's not biased. But we do have minutes to run these tools. Again, the commercial tools are going to struggle to run in that kind of cadence. And that's why we see pushback against them and maybe the adoption of open source. Still, if our asymptote is continuous integration, there is a low ceiling on what we are able to spend in terms of time there. And I think we see that in terms of the suffering as it pertains to the use of the more thorough tools, as well as frankly, how much is happening from a test perspective and coverage. IaaS typically imposes a performance penalty on what you're testing, but doesn't have a scan modality. In other words, it's always running as continuously producing results. So people have begun to question whether they can rely on it in a positive way, again, because it doesn't have that sort of multi-minute or hour-long scan time. I want to talk a little bit about some of these tools that I've implicitly badmouthed to this point. Tools that take hours to run when scanning the code do so for a reason. And the reason isn't because their authors stunk. Quality takes time, and in particular, quality takes time and context. And so it's a lot harder to consider all of the intermediate objects and all of the rich metadata that's created as a result of doing a build than it is to just scan and and semantically parse source code that's being checked in or out. That richness of what the type inferencing is and how control dependence or data dependence begins to evolve as you build software allows, frankly, very unique findings and more than half of the findings that a commercial stack analysis tool will find to be unique to those tools. And there are plenty of classes of vulnerability that can only be accurately found through those means: full program, build-aware static analysis. And so I think there's a place for those tools. I don't know that they need to be run on every build or all the time, but certainly I would say that failing to run them ever will definitely create a visibility gap that will not, regardless of what other vendors will tell you, be cleaned up by IAST or other sort of challenger techniques. The question is how we navigate the trade-off between thoroughness and our desire for low latency and cadence upkeep. When we publish doing things like hardening, signing, asserting the provenance of those artifacts we're creating, those are important tasks. Again, they have to fit within the asymptote of continuous integration and continuous delivery. So we have limited amount of time to do that. However, it does seem like we have more, and maybe this is just a function of maturity, more than minutes to manage the elements of orchestrating the deployment of our software effectively. We may build pretty much constantly. We may even deploy elements of microservices constantly, but when you really dig into firms doing continuous deployment, which is less common than continuous integration, what we find is that firms are continuously building, and they may be continuously deploying, but there's a lag between what they've deployed and when it got built. So the code that they're deploying continuously may be as much as a day old in some firms' cases, or it may be an hour or two old. And so there's a pipeline, and that pipeline has non-zero length to it. Telemetry accompanies each element of this, and I want to talk about these things individually. When we look at it, we've been collecting telemetry from production forever. SIM and other technologies have tried to help us take this avalanche of data and turn it into something actionable. I don't know that we're succeeding as an industry there, but we are making progress. One of the reasons we're not succeeding has less to do with the technologies that we're choosing and more to do with convention. If we're cobbling together our systems through microservices, correlating back who is responsible, what pipeline is responsible, and where an event belongs, ends up being much more about labeling and convention and much less about the SIM technology. And so that's where firms are spending a lot of DevOps time establishing those labeling and conventions around their orchestration, around their containers, and around production and logging so that they get that data back. And so you see that reflected in some of the telemetry that has begun to pay attention to things like Kubernetes, Envoy SDIO, as well as the container creation, container security, and container registry management software. Because software's behavior is so dynamic, it's not really possible to make good assertions about the security posture of the software based on purely proactive means, like that legacy touch points and lifecycle governance view showed. And so, with the orchestration software and with container management software we currently have, we now have the scaffolding to answer questions, how is this thing going to behave more effectively? Again, it becomes about coordinating that data and pushing it back to the right people. That data becomes more actionable for a developer when they get better telemetry off of their repos and their builds to help them understand and chase down the root causes of the behaviors and the symptoms they're seeing later from those other pieces of telemetry. And so we need to combine actually all three of those views in order for development to be seen as agile and resilient against the things that are being found in production. And so only by combining all three of those phases, elements, however you want to view it, of telemetry, can we give development and operation enough data to make a decision about who is going to attack the problem, how, and in what phase of the life cycle. When you take a step back and think about what we've just talked about in terms of this life cycle, you see a lot of similarity between this and the quick and dirty discover what you have, instrument to gain telemetry on what you have as it moves through its life cycle, and then provide hooks into the various pieces of the life cycle management to harden or secure. You see that this life cycle and that new view to what matters in the security initiative are highly related and complementary. And you also see, I hope, within this view, some of how you may think about tackling some of the challenges of digital transformation as it pertains to the lifecycle governance phases couched this way. One of the things that a variety of the surveys we've conducted thus far have shown us is that when you break things down into these lifecycle phases, some of these phases are well supported by security tools, many are not. For instance, I talked about a plurality of code being orchestration-based or infrastructure-based. There aren't good scanning tools for that. We're just now starting in the security vendor space or in open source space to see support for pull requests and that kind of first phase that was largely redacted in prior diagrams of open source selection. Publishing and hardening is something where there's a lot of fragmentation in the market. Let me put that a different way. One cannot tackle the security overlay to this lifecycle by buying vendor tools. Few of these things are handled as a capability delivered by a single tool. Gartner believes, perhaps apocalyptically, that you may require 10 to 30 tools to accomplish this task for larger and more mature firms. And worse, in container and cloud security, they believe that a plurality of the tools you choose as a firm may not be available to you in 2.5 to 3 years due to acquisition, due to failure of the business, or some other factor. Can you afford to wait and sort of avoid the problems Gartner has pointed out there? I don't think so. You have to choose carefully, and you have to have a strategy for dealing with fragmentation. That's probably one of the reasons why people have done so much in a home-rolled fashion. Because at least then the problem's on their plate. There are some, life preservers in the water. When we look at the pipeline platform tools, things like Red Hat's OpenShift, things like GitHub, things like GitLab, I think they're really going to dominate the innovation in this space in supporting this life cycle for the foreseeable future, the 3 to 5 years. Taken from the perspective of this diagram, we're looking at definitely the bottom half of it, but we're also seeing pretty rich entrees into artifact repository and orchestration, from these vendors. And why are they successful? Why will they dominate innovation? Well, because they're meeting development and ops on their side of the river as compared to security. These are tools that development and operations already uses on an hourly or daily basis. And they're tools that those firms are using to define their software lifecycle, if not the broader lifecycle. This allows security to become BAU, or business as usual. And in fact, when you look at something like GitHub, you see that security has been made business as usual, just like other things, just like insights, just like documentation, just like testing, just like social. And, we talk a lot about in security, this notion of, we call it different things. I call it zero interface, blending in, making security everybody's responsibility. What does that really mean? Well, it doesn't mean that someone's going to log into your security vendor dashboard. It means that the security dashboard needs to become part of the business as usual dashboard, which is development and pipeline management. These platform tools are also commoditizing elements of both the legacy and the modern vulnerability discovery capability set. So multiple pipeline platforms will provide you composition analysis by default and for free. Some of them will provide you static analysis through open source and give you the opportunity to integrate there if you're using open source for free. Typically optional. These things are harder to weaponize than composition analysis, so they're not on by default yet. And some firms are actually helping people by doing things like plugins for secrets management, or making sure you don't check in credentials, either for free and by default or for free. Because the security lifecycle is more than vulnerability discovery, because it involves things like coordinating disclosure of things that are discovered and may affect customers, or coordinating the crowdsourcing or security researcher sourcing or the bug bounty sourcing of vulnerabilities into product management. We see that people are doing vulnerability discovery as well as community or crowd coordination through these platforms and through these platform provided features. And some of these platforms, just like forward-looking security vendors, have begun to do flirtations with auto remediation. So you don't necessarily need to buy a commercial platform to manage your vulnerabilities or to manage the orchestration of some of your security tools. Obviously, firms like ZeroNorth are building out platforms to manage and provide enterprise-class features around some of this stuff, and to provide an agnostic view of things in case you have development units that may use GitHub and may use other things. Being able to provide a single platform that intermediates the challenges of the pipelines as well as the security vendor tools may be something you need an agnostic party to help you handle, as well as the services support that come along with that. But at the end of the day, again, these tools are doing a lot for free, and we should expect generally that as more of the world believes that security is its responsibility, that these things will get baked in to the Happy Path tools. At this point, I'd like to switch gears a little bit with the time we have remaining, and say that when I've given expanded portions of this presentation to folks, they've had a lot of questions, or it's generated a lot of discussion. And so what we've done is we've collected some of those questions and some of that discussion into some cached questions, which we'll dialogue here with the organizers and create a bit more of less of a monologue. Okay. So hopefully you guys will enjoy that format, but I'll also repeat that feel free to type your own questions into the tool, and we will cherry pick those and address them. If we don't get to them, we may acknowledge them, we may not, but I have in the past followed up individually with folks because I want to make sure your questions get answered. So please, by all means, enter your own questions, and we'll try to address them all. Thanks.
Yeah. Okay. All right, great. So yes, as John mentioned, we do have a couple questions that the folks over at ZeroNorth have received in the past. And if you want to go ahead and advance your slide, John, to the first question here. can centralized governance coexist with engineering-led security culture within a single firm? And, I think this is an interesting question because culture seems to be such a huge hindrance to integrating security into the DevOps pipeline. And I'm wondering if that's kind of changing as more organizations see they realize that security can be integrated by shifting left in the DevOps tool chain, and it's a tough job, but it's obviously doable. So what are your thoughts there, John?
Yeah, so this is very interesting and contentious, and I've seen personally a range of answers to this question. There are firms where the politics and the personalities, dictate the answer is no. You see certain verticals that are very organized around centralized governance. They may be highly regulated, they may be finance or have some other affinity like that. And then you see firms that are more engineering, that are more likely to be engineering-led. One of the things we're seeing where they do exist effectively together is that a legacy centralized governance or a new and empowered CISO organization is saying we need to audit, we need to trust but verify, but we will allow the engineering culture to decide how they're going to provide that sensor data for us. And in that way, they're working kind of hand in glove, where engineering is driving, which you saw in those life cycle diagrams and some of the charts. They're deciding what kind of sensors they're going to apply where, and what kind of telemetry, and how they're going to plumb that telemetry. And the centralized governance function is sort of feeding off of that, ingesting that material and making their own risk-based picture. And so where they've worked effectively together, governance is driving the policy, governance is driving that centralized and coherent view, they're driving scoring, they're driving attestation to the fact that the governance is occurring. So what and why, and engineering is driving how and when. And they're picking those elements of how it gets implemented, when in the life cycle it gets implemented, and that has worked well together. Probably a majority of firms are sitting in the middle, where there's still some tension associated with that hand in that glove.
Yeah, I think that if you had been asked this question a year ago, I think the answer probably would have been completely different. But I think we are kind of migrating more toward the happy medium there.
Yeah, so completely agree, and I would say in particular about 18 months. So we did the DevOps survey about 18 months ago, and we asked the question, what does an engineering-led security culture actually entail? What does it mean? And before that, in the BSIN 8, where we had gone out and looked at about 200 firms and understood what they were doing, we knew that there were central governance organizations, and we knew that there were some engineering-led security cultures out there. But what we found was the engineering-led cultures were driving all of the actual firm-wide change through the central governance function. They weren't themselves leading it. So they were almost like they were being delegated to in some sense. And the big change over the last 18 months has been that we see engineering-led cultures measurably effective in changing the whole firm's risk posture and culture. So I think you made a very good point there when you said, there's been a shift in the last 18 months. The data actually bear that out, which is interesting.
All right, great. Let's go ahead and move on to the next question then. I think, in the interest of time, that notion of being able to kind of pick and choose security tools for the DevOps pipeline is that a doable thing? Can the organization wait to adopt the fragmented elements, or is it more of an all or nothing proposition?
This is probably the hardest question we wrote down to answer. I don't think people can afford to wait. One of the things I tell everybody that I speak with who runs security initiatives is you've got to roll up your sleeves and you've got to begin coding. And if you can't do that, then you've got to get the staff that can or co-opt the security champions that can. There's plumbing and there's glue and there's customization that has to happen to these fragmented tools. You can use your industry resources and your peers and your own firm to help you answer questions like, is this firm going to be around? Can I rely on it? Is it a good platform on which to base some of my customization? But you have to pick some winners and begin implementing now. You can't wait.
Okay. I imagine that's going to cause some consternation among some companies that are not known for betting on the maybe the lesser known horse in the race. So that's also that's going to be a difficult thing for some companies to swallow, I think. Okay, so it's 8:50 or it's 11:56, 10:50. I'm on Pacific time, so I'm not sure. We're 4 minutes to the top of the hour. Okay, so GitHub or Azure DevOps, you actually showed in your presentation the value that GitHub and I think you also mentioned OpenShift, those are providing in the DevOps toolchain as far as providing kind of a security buckle, if you will. But is that it? I mean, should the organization just kind of rely on that for their security and nothing else, or is that just too easy?
So interesting. When I was asked the question, it's funny. You would almost think that I didn't write these questions down, and yet here I am. These platforms are actually providing more feature richness and less friction to developers than a lot of the vendors out there. That's the interesting part, especially as it compares to like AVM or TVM as a space. And it's the orchestration piece, the ability to integrate the security telemetry with the pipeline that matters. Mm-hmm. Now, they've really been confined, as you saw from that slide, into what they can do. It's the easy stuff and the open source stuff. And so, for most of the people, attending this webinar, they're going to say, yeah, but, I have a lot of commercial tools. I've really staked a lot of my program on that. And these tools aren't going to be, a day one fix for that. I think a lot of this is a platform play, and a lot of it's something where you've got to pick a partner to help you work through both the design, and I mean that both technically and conceptually, as well as the implementation of some of these things. And so even firms that have picked one of these platforms to drive their security telemetry have had a lot of work to do in implementation. In vulnerability discovery, we found that our customers were saying, we're going to spend X on a tool license, and we spend 150% of X every year on implementing the tool, and it never goes down. What the heck? I think everyone always underestimates the implementation cost, and I think in particular with orchestration and cohering the visibility into a single view, I think people have underestimated the cost of that, and really do need to pick a partner to help them get through that conceptual design and implementation. Obviously, that's something ZeroNorth does. Some firms have enough expertise in-house to do it themselves. I've spoken with 13 firms who have built their own based on things like Azure DevOps or GitHub, or frankly rolled their own from scratch. Just as a feel for it, those firms have spent on average 3 years, and they've spent between $8 and $10 million fielding that technology for their own organizations. Good news is they get exceptional customization to their environment because they built what they wanted. Bad news, it's a lot of time and money, and there's probably a long tail on it. And so, I think this is an open question. I think that these platform plays will get better. I think picking a good implementation partner is essential, or making sure that as a firm you assign the right level of resources to it.
Excellent. Okay. Gosh, and you have more community questions, but unfortunately we are bumping right up against the top of the hour. So we're going to need to close this out now. But which kind of annoys me because I really like the next community question. I think that would have been a nice conversation, but another conversation for another time. So, John, I do want to thank you for giving such a great presentation. Yeah. Lots of really good information there, and let's do this again soon, hopefully.
Yeah, maybe we can do a roundtable next time.
Yeah, oh, that'd be fun. That'd be fun. Okay, well, I do want to thank everybody for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thanks, everybody.